Hello guys, welcome to our webinar. We will wait a bit because we are seeing that currently we have got 25 attendees. It's still looking that people are coming, 26 now. So we will delay it like 1 to 3 minutes just so everybody can come at time. We will have it as our CTO presenting the slides, having some kind of talk about it, about our efficient testing strategies. We will try to have some kind of form of discussion. So you will be able to ask questions here on the chat. After a few slides, I will just be, as a moderator, asking those questions to the Greg. And then later we'll have got more general Q&A session at the end of the whole presentation about the Cobio, about maybe some kind of other things outside of this webinar, if you would like to. So we will wait a bit more. We have got 27 attendees, like 1-2 minutes, if you can wait. Meantime, if you don't know who we are, I recommend to go to the cobio.com site. You can see there what we are doing, who we are hiring, and getting some kind of more information about our company in that case. I see a few people already are saying hello, waving the hands. And Morten is always helpful. Morten is our UX UI designer, a really nice guy. As you can see, he always tries to help to everybody.
I'm actually curious, who is from Poland? Because we have two offices, one in Copenhagen and one in Warsaw. Who is from Poland? Cool.
A lot of powers are from Poland.
Nice. Szczecin. Nice.
Okay, so I think that we are ready to start. It's almost 11:03. So I'm giving the voice to our CTO, Greg, and let's start the presentation.
All right. Hello, everyone. My name is Greg. I'm a CTO at Cobiro. I'm Polish myself. I've been in the company for about a year right now. So I've been really building the whole Warsaw office from the beginning, from this year. And here we have like super talented people working for us, and we've been focusing a lot on things like testing and quality software from day one. A lot of stuff that we do is pretty much a greenfield projects, so we don't have a legacy. But so the presentation I'm gonna hold is like talking a lot about like how can you actually make efficient strategy in testing, and I'm going to give you a lot of tools to actually implement that, and then we're going to talk also a little bit about the legacy projects later in the talk, but for now, like, think about like fresh starts. Like, this is what developers like the most. So we have to start with a bit of a theory. I'm going to try to skim through it, but I think it's important that we agree on some sort of a set of wording, and when I say about some things, that it actually means something to you in the same context, because the topic of testing is very broad, and a lot of people interpret, there is at least like 2 or 3 ways to do that. So let's start with the basic theory. So the very basics of what we do is pyramid of testing. So on the top of the tests, we use end-to-end testing or UI testing as well. They're in the same category sort of things. What do we mean by end-to-end testing? So the presentation will hold things about the front end and the back end at the same time. So on the front end, that could be like a UI testing, and on the back end, that could be my feature testing, like shooting the request. So think about it like a black box testing. Then integration testing, it's a hot topic as well. What we mean by integration testing is when I have a service, how do I test that service connecting with another service? Or maybe my front-end application with my back-end API. This is really what we mean by integration testing. We use specific tools for that. We're going to talk about it a little bit later. But some people think about integration testing as like a module between. What I mean in my presentation by integration testing is the actual, like from my application to the outside. So it's sort of like a gray box testing, you can think about it. And then the unit testing, the holy grail of testing. So pretty much testing my modules or classes with all the inner dependencies in isolation. So whatever is outside of my class will be mocked, and whatever is inside, I will try to use it as much as I can. So that's the unit testing. Yeah, so let's go a little bit more into another core value that we have at Cobira, which is test-driven development. So when we do, like, TDD is what you're gonna do from day one working with us. Like it's a core value. Like everything we do TDD way. So I will not go like a lot into details about why you should do TDD. I will just tell you like how was the flow like. So the first thing, you wanna run the test, write the test that is failing. Then you wanna write a code that's passing that specific test, and then you want to refactor. So refactor is like a very small cycle part of what we do, and whenever we touch some code that's not tested, we also try to cover that with tests. So it's like a little Boy Scout rule that allows us to improve the code continuously with small iteration. The cycle should take like 2 to 5 minutes. And that's pretty much what we do. We don't go ahead and refactor. Like refactor is part of our job all the time. So why do we write test first? We have 100% code coverage, of course, but we don't do it for the code coverage. Like by the fact we actually run the same lines of code multiple times in our testing. We can have happy path and sad path testing. So the idea is that we want to think before we write the code. That helps us to write high testable, highly maintainable, and code that actually adheres to our other values like solid principles, dry principle, design patterns. So we think about it when we actually write it before we write the code, and then we just generate the code based on the specification from the test, and the thing goes very, very fast. And one thing that people usually say when they come and work for Cobira is that TDD makes me go slow. Well, not really. Actually, it makes you go a lot faster. It's because we have the layered model. So like the classical example, we support many different architectures, but generally, let's take like classical example, user interface layer, application layer, domain layer, and infrastructure layer. If you want to test infrastructure layer, like the bottom layer, it will take you a lot of time to actually spin up this Angular app or spin up your service and make the request to your API and go all the way down to like your repositories or whatever is the pattern you use for communicating with database or other services. That's going to take you a lot of time. But here, when you test in isolation, it's going to be a lot faster this way. So it's actually making you go faster. And the other thing is you don't create a lot of technical debt, so you are a lot more predictable going forward with your estimates. It's not like new project, everything goes very fast, and then you drastically drop. No, pretty much a constant line because we refactor and do the TDD all the way. All right, I give you some more theory. This slide might be new to you, actually. So this is contract-driven testing. A lot of people ask me, what is CDT? Well, it's contract-driven testing. The way it works is that we have two parts of the deal. We have a consumer and a provider. And then a consumer will define a contract with the provider, and then it will be able to use the mock provider server and start making us features all the way. That contract will go to the cloud, and then the provider can download it and make a mock consumer. And that way, it can actually shoot the request against its own API and see if we are in sync. So it solves a lot of problems. We can talk about it a little bit later. But the major benefits of it is that I can now parallelize my efforts on the backend and the front end. I don't have to wait for backend to be done with the endpoints. I can actually create it together. And we have a cross-functional team, so backenders and the front-enders build the same thing. at the same time. So this really helps us to speed up the process. And also it verifies each time when the, I don't know, maybe backenders make some optimization that turns out to be breaking the contract. Well, they can't push that code because it will get checked. So we're going to talk a little bit more about it, and I give you some more hints how to actually write that code, both on the consumer and the provider side. But for now, I want you to know that we have the tooling ready to the contract-driven testing. Okay, another big factor of what we do is testing quadrants. So testing quadrants are different, 4 different types of testing you can be doing. The green boxes means the automatic tests, and the red box means it's manual test. So normally what we do is we have on the horizontal axis, so on the you have a division between the technology and the business, and then on the vertical axis you can divide between the team and the product. So let's start with pyramid of testing, the stuff I already discussed with you. So here we have all our end-to-end unit tests and integration tests. This is done by the developer. And then we have the acceptance testing. This is actually made very similar to the unit test or integration test, but the way it works, it validates the business. So pyramid of testing can verify your software, which means you are sure your software works. But the acceptance test will validate your software, which will tell that your software does what it expects to do. So here we will put like the real live data, like the real, we will not do like fuzzy testing check-in, I don't know, for the negative values or something like this. We will actually go and put like the real use cases of our business rules. And then we have a performance testing. I'm not going to touch a lot about that, is because it's usually like the DevOps part of the deal, but it's supporting the product, it's testing the load times, it's testing the, it could be things like also security testing would be in this quadrant, but generally we would check, how many requests can we make, what happens if 100 people go on our website, and things like this. And then we have exploratory testing. This is manual. We keep the manual testing, but we don't test manually just to see if the software is working. I mean, this is why we have all the other quadrants. Here, we want to get inspired to create more cool features going forward. So like a product owner will, we will do the demo for our stakeholders. Every sprint we end with the demo, and then they would go ahead and test the software, and they would click around and then get inspired. What is the next killer feature that we can build? And the same is with the qualitative testing with the user. So for example, we would have a group of the users that would invite for the sessions, and then we would see how they actually interact with the software, and then we will know, remove all the UX issues they might encounter. We could actually, speed up the happy path of the user. I hope that makes a lot of sense. The last thing I would like to touch upon is that after we did the TDD, we said, hey, let's go one step forward and let's do a TDD. So it's sort of like builds on the idea of BDD, behavioral driven development, but it's really acceptance testing driven development. So the way it works is you want to start with the failing acceptance test. Then you want to go ahead and start building your TDD cycles inside. And then once you finish some cycle, you want to go to the passing acceptance test. And then the passing acceptance test goes again to the refactor stage with the product owner, where you can do some exploratory testing and come up with some better ideas about building the software. Not building the software, but building the product. Okay. Do we have any questions? Mm-hmm.
I have got a question to you, Greg, about this ATDD. So what does the refactor part means exactly here? Is it product owner that decides what is to be a factor, or developer?
Yeah, so here we would really so the team is cross-functional, so product owner and developer, so everyone is welcome with the input. But in general, yeah, that would be the part where developer might come up with some great suggestions, like a front-end guy could say, this button feels a little bit clunky when I build it. Maybe we can actually change it a little bit. Or maybe that shouldn't be a drop-down. Maybe that should be a radio button. That would make more sense. And then that would be the developer-driven. But a lot of times it would be product-driven or even customer-driven. So the cycle could represent a single user story being implemented. And then the next cycle will end up with a new story being made. Does it make sense? I hope it does. Do we have any more questions about the theory part, or should we move on to more tangible stuff?
After this theory introduction, we can move to the more interesting stuff in the code.
All right, awesome. So let's talk about developer experience. So I mentioned a lot of theory, and it might be like super fuzzy still for you. So let's talk about what is it like to actually work using those strategies. So let's meet three people. We have Anna, which is the product owner. We have Tom, who's a front-end engineer, and then we have a Ben, who is a back-end engineer. So all team meets on the, of course, they meet on the refining sessions. We have a full Scrum implementation, but let's just say we have a planning session, right? So Anna will come in and say, I have this acceptance test. So she will not say, I have acceptance test. She has acceptance criteria that are written in the form of a test. So we will have like given, when, then. We use the Gherkin language to describe the specification. And that way, we want to also keep it on acceptance test level, in which the front-ender and the back-ender can actually take the same test and put it in the code base and just have a failing test already. So how does it look like? Well, an example of the feature could be like this. This is a feature with only one scenario. Normally, you would have multiple scenarios, and you would maintain it all the time. So here we have a feature for the cart, and then we say, scenario says, as a user, I want to add the product to an empty cart. So you want to start with the preconditions of your test. So you want to go with the given steps. And then when you see those little ends, it really means it's a continuation of the previous statement. So in this case, it's like given, given, given. So let's hear it out, how it sounds. So given I'm on a web shop on site with ID 123. So here we want to build the context around our application layer. So we want to provide it with this information. And then given I have an empty cart, so we want to actually create an empty cart. So that translates to the code lines in the behat on the PHP side. So in here we would create like have a factory or some other creation or design pattern that will allow me to create an empty cart. And then there is a product with ID, whatever good we use UUID for here, available. So we want to also make sure that the product exists and it has an available status. So it could mean many things. It could mean there is a database being seeded with the product of this ID and with that state, or it could mean we actually mock an external dependency to another service. I can tell you a little bit secret. This one actually seeds a mock server in the packed setup, where we mock an external API called Product Center. So whenever the underlying code in the infrastructure layer will actually make that call, it will return a product with that ID. And then there we have the action, the when action. So when I add one product with ID to the cart. So that means, of course, there is some UI related to that, but here we want to move away from the UI. The reason being UI changes a lot, and you don't want to depend on the UI. And in the backend world, it could mean your UI today can be a request, but tomorrow it can be a message through the queue, or it could be a WebSocket, or it could be GraphQL. You don't know what is it. So we want to move that away. We want to decouple the UI from the application and the lower layers. And then that will actually, in our backend, it will translate to the command bus command being executed. This helps us to scale this and have the acceptance test written like this. Because remember, acceptance test should test the business. They shouldn't test the UI. So, and then we have the post condition. When we say then the card should contain one product with ID. It could be as simple as going to the database and selecting the card that has, and check if the product has ID like this. So I hope that makes a lot of sense. I'm going to show you a little bit more from the front-end side, how it could look like. So in the front end, we also decouple the UI from the application. So an application layer, like the entry would be a store. I hope you're familiar with it. So for those who are not, a store will represent like the command bus, really. I mean, it's a little bit more than that, but don't get me started. But generally, think about it like a layer, like a very thin application service that I can use in order to dispatch my commands. So again, you see, you don't need to write a Gherkin language everywhere. I mean, if you don't have a Gherkin language, don't do it. Just document that in your code. So in here, we put a command where we say, given a website with a single homepage. So here we have a stub of the state of our application, and then we would reset that state using the page state stub, and we say homepage only. We would create tons of this, and there is a lot of design patterns you can use. We can use assemblers, we can use even factories, we use page objects in our UI testing. So there's tons of things, but this is a whole another topic that we could cover like in hours talking. But what is important? So after the given comes the when state, and the when state, it dispatches a command. So here we say when I want to add a new contact us page. So here we go, we create a command with the contact us page. And then I should have two pages, well, the home page and the contact page. So we have a selector on the state, and then we select if the state contains two pages. And I should have a page with link contact us. This is a business rule. Like, we really decided that it should be a title with the contact dash us, not underscore, not contact us together, that we should replace special characters and you name the business rules. And it should be in your acceptance test. So we don't know anything how it actually works under. We know what we expect from the state. So this is acceptance testing. So the next thing you would, so this is already implementation, but the next thing, come back to the planning, what we would do. Tom and Ben would identify all the integration points that they need to make. So let's give a very simple example. Tom and Ben needs to make a post request with two V1 users, and then it would provide the request payload, and then it would also provide the request headers. So they have to agree on this because it's the base of the contract making. So let's have a look how the contract can be made. So here is an example of the backend contract. So here we go to the infrastructure layer in which we have our services, like a Guzzle service, making a call to another service. In this example, we have a test that will make a call to the product center. And then we have this mock server instance. So mock servers represents all the mock servers that have been spawned up, and then it gets a specific one called product center. And then we want to seed it. So we want to send it an interaction. An interaction is a PSR, request response. You probably build that. So again, the developer experience, we want to make it as developer friendly as possible. I think we're gonna open source that library eventually, but generally think about it that I want to make a request, which is a get, and I want to specify the path, and then I want to specify the headers, and then when exactly that request comes into the mock server, I want to specify a response. And then there is a little bit thing called provider state. I don't want to get to that just now. I want to keep it simple. This is whole another talk. But generally, what's important? An important part is that the product will get returned from here we call it product repository because we want to abstract away using dependency inversion that, it's repository no matter if it's a database or HTTP call. But I mean, clearly you can see it is an HTTP call. And then I want to load a product with this ID. And to the version of API, which is 1. So this way, we can build, this will actually make real call. Now, you might be thinking, okay, but it will make a call to the real product center. Well, hopefully you use the client configuration in your classes, so you can provide different base URLs. And then if you do that, you just switch the base URL from the real server in production or staging or whatever to the local version of that service. And that way, we make an interaction, and when the service makes a call, it will get the response. If it's all good, it will get the response specified here, which is the 404, or it will actually make 500, which means an error. And that way, the product repository can actually, react to it accordingly. So this is a TypeScript version of it. So you see, it looks pretty much the same, so it shouldn't be that much more difficult. So we have something called provider manager that represents managing the different provider mock servers, and then you want to add an interaction, this time to the website service, and then you want to make a packed request. Packed is the tool we use. We're going to have a whole session about packed eventually, but here we want to make a put request for the specific URL with the specific body and specific request headers, and that should actually give us the no content response with the specific application header. So if you look at the each section, this is how you execute tests in JavaScript, in Jasmine. And then we have a real instance of the service, and then we want to say save themes, and that will actually use some parameters that are in sync with the requests, and then it will check, if the response is truthy. Otherwise, it would get the fail error. So it looks pretty much the same. So this is how we actually test our integrations. And then in the middle of the sprint, whenever product owner in the refactor stage, for example, can decide to alter the smoke test or regression test because the UI changes, and we want to keep some UI testing and end-to-end testing, but keep them to the minimum. So again, the pyramid of testing. So what can happen here is that Anna can sit with Tom and define those elements, and then it can talk about creating a happy path or sad path for the users, and then see if things still work. So those tests, we don't want to execute on every single commit. We use the continuous deployment, so we deploy multiple times a day. So we don't want to actually test that all the time, because that test suite can run hours if you want to have a full coverage of a UI. So we definitely want to run the smoke test after each deployment, just to have a sanity check if things work, and it will simulate a user with like the most common path. And then we want to also use some regression tests, and whenever a bug appears, we also want to document that in a test so it doesn't happen again, or it gets checked. And that way we execute it like once a day or something like this. So it's not affecting the developer flow, but it gives the feedback one time a day. So how does it look like? So look, here again, we have a Gherkin language. So as a user, I want to start adding a page and go back without changes to page list. So in here, I don't want to read it out all the time, but I want you to focus on the difference. The difference from acceptance test is that here we are very UI related. So for example, given I'm logged in as a test user and builder page, you could do that in integration in acceptance test too. But here are the next one. And I am on a desktop device. In acceptance testing, you don't have desktop devices. Here you hit the UI, so you want to have a desktop device that has a specific width and height of the browser. We use Cypress for this. It's pretty cool tool, actually. And then you have the when stage. So here we can execute multiple actions that the user should do. So you see, it's like a journey. It's not like a one scenario for a specific case. It's actually a journey that the user can do. So here we go. When I open pages in the side nav, so UI related. When I press, when I type, when I press. So you see, pressing symbolize an actual buttons. When I follow would symbolize links. When I type, it could be a text area or input fields or WYSIWYG editors. And then the final one, then I should not see something on the list of pages. So it's actually pretty interesting. So you can see when I press the back button, well, even though I set it up, the whole thing, then I shouldn't see it. So this is a regression test. This is when we actually realized that, I don't know, maybe there was a constant syncing with the store on the front end, and then we realized that after clicking the back button, you actually still see this page, even though you didn't accept the save button. So this could be one example. Okay, so let's talk more. So let's say the sprint started. So we already talked slightly about the failing acceptance test. So we get the Gherkin language. Now the developer first will actually, set up all the, application layer, will set up all the DB repositories, or not necessarily DB, like infrastructure setup, which would actually seed things, mock things, and then would make an assertion at the end to check if DB contains it, for example, the one I explained before. And then obviously that's a failing test, nothing is done, everything is red. So then we go ahead into the TDD cycle and then we would implement that. Very interesting fact is that actually our teams consist of more people than just this, of course, but I just wanted to simplify it for you. But a front end would at least consist of the pair. There would be 2 developers. So we also are very keen on pair programming. It helps us with less code review, and it helps us with better understanding of what is happening and what the other people are doing. So then we can jump in easily and help out faster. So we have a context, and we want to actually make sure that we deliver the features together like a team. And then the backend will also do the same. So there will be at least 2 backenders that would actually work on the same, could work in a pair, not like all the time, but most of the time they would sync at least once a day to do some pair programming session. And then the TDD is actually very interesting exercise in a pair, because one person can write the test, the other person can write the code. So you actually challenge each other all the time. And then the refactor is much easier to do when you have 2 people working on it. Okay, so let's talk a little bit about the feature test. So a feature test is like UI test on the backend. So here we have an example of PHP feature test, which represents a calling, the black box test that tests the API from the outside. So here we go. We seed a DB, then we make a get endpoint with a specific URI, and then we want to assert the status is 200, and then we also want to assert that JSON got returned. So this is a very simple example based on the seeding. Normally, we would also check the types of the that the number should be really a number, that the order add should be a timestamp, and it doesn't mean it needs to be John Kowalski. It could be, we use very often with matchers, which represent an actual string-like types and stuff like this. But I hope it makes sense that, as a backender, I will still write a happy and a sad path for my endpoints. Here is a typical example of the unit test. So you see, well, we don't mock the dependency because it's like the last thing I have to do. This is a value object. For those who don't know value objects, I really recommend you to read about it. I don't want to now talk tons about it, but think about the value object like object that holds value, and it can also validate that value. So here we have a happy path. So we have a host that is a website host, and we say that the assert equals valid host, and then the name of that host gets extracted. So we have something called data provider. So we want to test more than just one case. So you can read it and already know specification. You can clearly see that we support the normal domains. We have a domain with a subdomain. We have domains with more than one TLD, so with co.uk, and also like a little bit longer subdomains. This is so normally what you would do, you would start, this is after many iterations, right? You don't write that test all the time. So you start with just, I can create the class. Then from that test, you would generate your code based on the specification you just made in your test. So it's not slower to write 2 things, because actually a lot of times we just generate our code from the test we write. So first we think what it should contain, what is its responsibility, following the single responsibility principle, and then just generate that class. It takes 1 second in the IDE. And then again, this is the same value object thing. It's just that now we want to throw an exception. So we also want to test that. So we want to test all kinds of domains with the slashes afterwards, or domains without the TLD, or just empty strings. We want to test that. Just be professional about your craft. Okay, here is an example of the value object test in the TypeScript. So again, it should create page title, the same thing, it should be defined, the value should be this, and then we also want to check the error that the value object threw a domain exception. Okay, so let's talk a little bit like a very brief summary. So Anna, as a PO, would be driving the acceptance testing from the Gherkin perspective. She would be also doing exploratory testing with the customers or stakeholders. Then Tom and Ben will focus on the team part, both technology and the business. They would be building the pyramid of testing using the TDD approach, and they would be implementing the acceptance testing using the ATDD approach, given a Gherkin language provided by Anna. I hope it makes a lot of sense. And I omitted the performance testing because of the DevOps, actually DevOps who does it. Okay, do we have any questions by now?
And we don't have questions.
Okay.
So everything is, I hope, clear for everybody.
Okay.
We can go forward.
Cool. We can ask questions afterwards, so that's no problem. Okay, so now you can come to me and say, well, Greg, you said that in Kobiro you do the Greenfield project, so you're in this very comfortable situation. What if I don't have a Greenfield project in my job? Well, I can think of two scenarios what you can do. I give you a difficult one that you can solve the difficult way, and I can give you the easy way. So let me start with the difficult one. So difficult scenario is you want to invert your pyramid and create something called ice cream cone of testing. So you want to have more. So hopefully you are in this situation. Well, not really hopefully, but hopefully at least in this situation. If you don't have anything, start with sort of a thing like this. If you have a legacy software, you want to base it on the manual regression testing. I mean, sorry, that's how it is. I wouldn't recommend do it in your every feature lifecycle. Do it before the releases. And then you want to eat that ice cream from the top. So first you want to eat the regression testing and start automating it. So move as much regression testing into automatic fashion. Have your QA or have anyone in your team, engage your QA, front-end developers, back-end developers, even your PO, to actually start defining the infrastructure for the end-to-end test and automate as much as you can. Trust me, a lot of this stuff can be automated. Maybe some things can't, I understand that, then don't automate it. Start with the low-hanging fruit, something that is easy to do. Then, depending on your situation, whether you have multiple teams with multiple APIs, you have a lot of communication, integration testing is very important. If you have a monolith application, not so much on the backend. Then focus on front-end to backend only. And then start building your unit tests. How to do it? Well, engage in the TDD cycles. Start building the code this way. And I understand legacy code, spaghetti code problem, and God classes. We all been there. But I mean, start doing this. Start writing the code that actually is testable, and educate your fellow workers. Start working in a pairs. Get people to actually understand the value of it, and that way start making a cone with a pyramid of testing, and that way you can actually go further. So this is the hard part. Now, what's the easy part? Well, the easy part is hate your job and come and work for us. We are hiring. If we go to kobirobamboohr.com/jobs or go to kobiro.com, navigate to the career section and apply. We're looking for all kinds of skills. We support multiple different types of architectures, so there is a place for everyone. There is easy architectures, there are decent architectures, and they're like really advanced architecture, hexagonal, CQRS, and all those things. There is place for everyone. So what is really important? You need to be hardworking, talented person like us. We are hardworking people who really give our best, and we want to build great products, And if you're kind of person like this, if you really want to work in an environment where you want to commit to TDD, you want to commit to ATDD, you want to write those integration testing, you want to follow a proper Scrum, and have a cross-functional teams, and you want to be actually active in building the products, then come and work for us. This is the place. We're looking for people like you. So if you have any questions, you can always contact me on Twitter at orfo23, or you can contact me on my professional email, like my Kobiro email, greg@kobiro.com, and I'll be more than happy to help. So that being said, thank you all for coming, and I would really like to hear your questions.
We'll wait a moment for the questions to be asked. Meantime, just to not have a silence, I have got a question to you. You have shown this nice ice cream cone. Is it possible that we are not going from top to bottom, but skipping few of those layers? Like, I don't like integration tests because it's a lot of stuff to be written there. So I just want to have a manual test, then automated end-to-end, and then skip integration and go to the unit tests.
Well, the answer is it depends. Yes, it is possible. Of course, you can do it. Just think about what makes sense in your system, right? So integration test, what's the value of it? The value of integration test is that front-end and just an example, front-end and the back-end are in sync. If you have, like, for example, I work in a teams where so first of all, answer some of the sub-questions. Are your teams separated? Like, is the back-end and front-end separate team? Well, if it is, then definitely integration test is a very important tool to do. If you have cross-functional teams where front-end and the back-end, or even better, like front-end and back-end is a pair of programmers, then maybe they can agree. I've seen it working, that the integration testing were not needed. Do you have microservices? Well, or micro frontends? If you do, well, it's kind of important because like what happens is, one integration will fail and you will not figure it out. Do you have a monitoring in your production? If you do, well, it's much better because you can detect those changes quickly. If you don't, well, how else can you actually make sure things integrate? So you don't want to wait for your boss to come and say, hey, I cannot pay for whatever I want to pay on my website, or customers come and complain about something. You want to be professional about it. But you can do it without it. I personally seen it working without the integration test, but it requires different culture.
Ben, please, could you comment on how you organize the different layers types of the test?
Yes, it's a whole discussion. So how we organize. So as I said, when you do the TDD, you want to write the test first and then the code. So which means there is a very intimate connection in folder structure between these two sort of concepts. So think about it like when you have an accountant will not write like, I added this, I removed this. He will have two columns. One will be for the things that cost you money, and one thing will be for the things that bring you money. They will count all the way till the end, and in the end, the number has to be 0. If the number is not 0, something went wrong. So the same is with the tests. So we structure the way, so we follow the layered model. So I give you like the most common example because we also have hexagonal architecture and stuff. But think about it like this. I have a code. I decided, let's say what architecture makes sense is I have application layer, I have a domain layer, and I have infrastructure layer. Then in my code, in my test code, I will have each folder for each one of this. So for my application, I will have my acceptance test. For my domain, I will have my unit tests. For my infrastructure, I will have my integration tests. So in my, for example, infrastructure, I will have a folder, depend on what kind of adapters you want to have. Let's say you have only database. So I will still put it to the DB folder. And in my integration test, I will have a DB folder. If I have HTTP connections from my outside world, then I will create an HTTP folder. And in my integration test folder, I will also create HTTP folder. So they are linked one-to-one.
Okay, thank you. We have got another question from Justina. Should penetration testing or safety testing in general be part of acceptance testing?
I would put it to the quadrant that supports product. So let me go back to it. If you can see my slide, I think it should be in this quadrant. So it supports the product and it supports the technology because it's sort of a set of security. Nonetheless, if you do acceptance testing or pyramid of testing with like unhappy paths, that already covers some of the business covariance. But if you think about penetration testing per se, where you want to, I don't know, check for the security holes in your system, I would still put it here. And in our case, it would be DevOps who do it.
Okay, I have got one more question from Sisaba. I hope that I have pronounced it correctly. in the ice cream cone model, when you will define the schema and use it to the test against it?
So the question is, in this model, what will I do?
Will you define the schema here and use the schema to test against?
Oh, you mean like, will I schema from the database, I believe?
I think so.
Yeah. So database is infrastructure. Infrastructure is integration testing. So no matter if it's an ice cream cone or the pyramid of testing, it would be in here. So yes, I want to actually make those database checks. And since it is an integration testing, I would let it flow. So I would not mock anything there. I would just create an so depending on what you're using, right? Let's say you're using Laravel, then you would use eloquent models, for example. Or if you use Symfony, you would use your repositories. Doesn't matter what you use. It matters that, let's say in Laravel case, you would create an instance of your eloquent model, which would sync with your database schema. You wouldn't actually test the database schema. You would create the model, and for example, I want to create that model. So in your test, you would call the create or save on it, and then you would use the assert database contains, and then you would actually go ahead and fetch that thing from the database and see if it was saved correctly. In the repository in Symfony, the same way. You would create the repository around it, and you would test your integration. By the fact, actually, when we do the test coverage, we also do the test coverage of each layer. So when I test integration testing, I want to see how many of my calls and my repositories are being tested. If I have a less than 100%, I know I don't test something. So then I want to actually cover that. So we avoid the whole, for us, code coverage is not like coincidental code coverage. We really blacklist and whitelist some specific folders in our application in order to get the real code coverage. And there is a topic about the mutation testing, but that's for another call. I hope that answered your question.
Currently, we don't know. Cesaba, you can invite it back. I don't have any more questions. As I understand, probably nobody else has got the questions too. So we will finish this presentation. I recommend you to ask questions on the Twitter for Greg. Could you go back, Greg, to the last slide where you have got your address?
Absolutely.
So everybody can just see it, write it down. So if you have got some question later, you will think about it, just ask Greg on the Twitter. He will respond to you. And as I hope, we will try to soon show this presentation somewhere on the internet that it's available to go over the slides by yourself when you will have got some kind of time, or use it how you will fit it.
Yeah, absolutely. I will record it and upload to some sort of a YouTube channel, my YouTube channel, really, and then I will share it with the rest of the people, for the people who couldn't attend as well. There are some cases, pretty much. But also keep in mind that we also have a Meetup group here in Warsaw, so it's a little bit local now, moved from the global to local. So we're also going to organize more meetups going forward, at least once a month. So please stay tuned for the next exciting stuff. And if you have any particular topic or you would like me to talk or go more in depth about each of the stages, then please do and write it on the Meetup or write it on Twitter, and I'll be more than happy to do it next time.
Thank you for all the people that came here, ask questions, and be with us for almost 50 minutes. So have a nice day.
Thank you.
See you soon, within a month, probably.
Have a nice day. Bye-bye.
Bye-bye.